Chapter 1, Section 6 video notes. Today we're going to talk about solving equations that involve absolute values. Before we do that, let's talk about what the absolute value is. First of all, the absolute value, one way to think about that is the distance from 0. Now, from 0 here on our number line, you can always move in one of two directions. You can move towards the right, which is the positive direction, or you can move towards the left, which is the negative direction. However, distance is always going to be positive. For example, if we take two numbers like 5 and -5, they have the same distance. Their distance from 0 is going to be +5, because distance can never be negative. However, this idea of moving to the right from 0 on the number line and moving to the left from 0 on the number line sets up the unique fact that when we solve equations that involve absolute values, we have to allow for two possibilities, either the positive value or the negative value. So here's our key concept for today. When we solve absolute value equations, we're going to first isolate that absolute value expression. Then we're going to write two equations. One where the absolute value is set equal to the positive distance, and one, our absolute value is set equal to that negative distance. All right, let's take a look at a few examples. We're going to start off by just evaluating absolute values for these expressions. Well, the absolute value of -5 is the distance -5 is from 0. And we just saw that example up above. It is +5. The absolute value of 1.65 is the distance 1.65 is from 0, which is just 1.65. Remember, distance can never be negative. It's always positive. Here in letter C, we're going to evaluate what's inside our absolute value bars. This is the opposite of the absolute value of -3, because 33 divided by -11 is -3. So when this negative appears on the outside, what we're doing is really taking the opposite of the absolute value of -3. The absolute value of -3 is +3, but the opposite of that is -3. All right, in example 2, we're going to jump into solving absolute value equations, which, remember, our first task was to isolate that absolute value expression and then set up two equations. All right, we're going to solve both of those equations. One set equal to the positive value and one set equal to the negative value of that other side of the equal sign. Example 2a says 1/2 the absolute value of x plus 6 is equal to 11. We're going to move this 1/2 over to the other side by multiplication. So we're going to multiply both sides by 2. That will eliminate that 1/2 in front, and now leaves me with absolute value of x plus 6 is equal to 22. Here is where we are now going to set up two equations, one set equal to the positive and one set equal to the negative. All right, once we have those two equations, we can drop our absolute value expression and just solve the equation. We're going to solve that by subtracting 6 from both sides. All right, that gives me x is equal to 22 minus 6, which is 16. Or we're going to subtract 6 from that -22. That gives me x is equal to -28. Now we should plug those numbers back in just to check and make sure that they do form a true statement. So let's put 16 back in for x. 16 plus 6 needs to be done first because absolute value is a grouping symbol. That's 22, and half of 22 is equal to 11. Next, we're going to put -28 in. -28 plus 6 gives me -22. But then we're going to take the absolute value of -22, which is +22. Half of that is 11. So both of these solutions check out. Neither one of them is extraneous. All right, now we're going to plot those solutions on our number line. -28 way over here, and I'll put 0 here in the middle, and then 16. When we plot the solution, we're just going to graph their little dots on the number line, indicating that either -28 or 16 can be a solution to that equation. Let's try example 2b. We got the absolute value of 3k plus 1 plus 9 more is equal to 4. We're going to start by isolating our absolute value by subtracting 9. That gives me the expression 3k plus 1, the absolute value of that, is equal to -5. Now this should be a little bit of a warning sign. We have an absolute value equation set equal to a negative number. Remember, absolute value is always positive. So if you ever have an absolute value set equal to a negative number, remember, absolute value cannot be a negative number. Therefore, we know right away that there is no solution to this equation. All right, in example 3, we have a little bit of a word problem here. You are riding a bike and are about 15.5 miles from your friend's house. The distance varies up to 1.5 miles depending on the route that you take. You are traveling at a constant speed of 8 miles per hour. We want to find the minimum and the maximum time it will take you to ride to your friend's house. Alright, so we are going to use that trusty little distance equals rate times time formula. And we're going to consider what that maximum and minimum distance could be. So remember, you start off at 15.5 miles, but your route could vary by 1.5 miles. So the maximum distance it could take you would be 15.5 plus that 1.5 more, and that's going to give you 17 miles. Alright, now if you had to travel 17 miles at a rate of 8 miles per hour, to find the time that would take you, you're going to take 17 and divide it by 8. And that's going to give you just over 2 hours. So that's going to be 2.125 hours. Alright, now let's consider the minimum distance it could take you. That minimum distance would be if you cut off 1.5 miles. So if we reduce that 15.5 miles by 1.5 miles, that's going to be a total of 14 miles. Well, that would be a distance of 14, traveling at 8 miles per hour. We're going to divide both sides by 8. 14 over 8 gives us just under 2 hours, which is 1.75 hours. So there is our minimum and our maximum amounts of time that it could take us. Alright, moving on to our next few examples, we have another key concept. What about solving equations that involve two absolute values? Well, we're going to follow this same strategy. We're going to set up two equations, and the first equation will be where we drop both of those absolute values and we set it equal to the positive form of that second equation. And the second one will be where we set it equal to the negative form of that second equation. So let's do a few examples and I think you'll see what I mean. Here example 3a says solve this absolute value equation. So here we have our two absolute values. They're already isolated. We don't need to do anything to them. So we are going to set up our two equations. We have 2m plus 6 equals the positive value of m, or we have 2m plus 6 equals the negative value of m. Alright, solving both of those equations now. We're going to subtract m over, and we're left with 2m minus m gives me m plus 6 equals 0. Subtract the 6 over, and we get m equals negative 6. Alright, our second equation, we're going to add m over. We have 3m plus 6 equals 0. Subtracting 6 over to the right side of the equation gives us 3m equals negative 6. Divide both sides by 3, and m equals negative 2. Alright, so our two solutions here are m equals negative 6 and m equals negative 2. Alright, let's take a look at example 3b, and I've erased some of our work here for 3a, so we have some room. We have 3 times the absolute value of x minus 4 is equal to the absolute value of 2x plus 5. So once again, we're going to set up two equations and we can drop the absolute value bars. However, when we do that, we need to replace these with parentheses. So our first equation here is 3 times x minus 4 in parentheses is equal to 2x plus 5, or we have 3 times x minus 4 equals the opposite of 2x plus 5. Alright, now we're going to simplify both sides and solve both of these equations. we need to distribute our 3 into the parentheses here. We have 3x minus 12 is equal to 2x plus 5. Now we're gonna add 12 to both sides here, and we're gonna subtract 2x simultaneously. So 3x minus 2x is gonna leave me with x, and a 5 plus 12 is gonna leave me with 17. All right, there's one solution to this absolute value equation. Let's find the other one. Again, we're going to distribute a 3 into the parentheses. That gives us 3x minus 12. And over on the right side of the equal sign, we have to distribute this negative to both the 2x and the positive 5, which will leave us with negative 2x minus 5. All right, now solving, we will add the 12 over and simultaneously add the 2x over. So we have 3x plus 2x, which gives us 5x is equal to negative 5 plus 12, which is 7. Dividing both sides now by 5, we get x is equal to 7/5. And we can leave our solution as that fraction. All right, so that is solving equations with two absolute value equation signs. Remember, you're going to set them up just like you did before. One set equal to the positive value of that right side of the equation, and one set equal to the negative value of that right side of the equation. All right, we're going to do one more example here today. Example 4, solve the absolute value and check for extraneous solutions. So we have our absolute value that's already isolated. We're going to write our two equations. 3n plus 18 equals positive 6n, or 3n plus 18 equals negative 6n. So let's solve these one at a time. We'll subtract our 3n over, and that gives us 18 equals 6n minus 3n, which is 3n. Divide both sides by 3, and one value of n is 16. Or we're going to subtract our 3n over, solve this one on the right side. We get negative 9n is equal to 18. When we divide both sides by negative 9, we get an n value equal to negative 2. All right, so our two solutions then should be checked to make sure they produce a true statement. When we plug 6 in, we're going to have 18 plus 18, which is the absolute value of 36, and that should be equal to 6 times 6, which is 36. So 6 checks out and is a true statement. Now let's check and see what happens when we put in a negative 2. 3 times a negative 2 is negative 6. Negative 6 plus 18 is absolute value of 12. Is that equal to 6 times negative 2? Well, absolute value of 12 would be 12, and 6 times negative 2 would be negative 12. This is not a true statement. So we would say that this value, n equals negative 2, is what's known as an extraneous solution. It looks like it might be a solution. However, when you plug it back into the original equation, it produces a false statement. All right, guys, try the remaining examples on your own, and we'll check your work in class tomorrow.